Taking a photo of the entire Milky Way galaxy sounds like a cool idea, but it's not that easy. The tricky part is, we're inside it. It's like trying to take a selfie of your house while sitting in the living room. We're stuck in one of the spiral arms of the galaxy, so there's no way to step outside and capture the whole thing. Even if we tried sending a spacecraft far away, it wouldn't help much. Our galaxy's over 100,000 light-years across. That kind of journey would take billions of years, way beyond anything we can do. So instead of taking a photo, scientists do the next best thing. They map the galaxy piece by piece. Using powerful telescopes, they look at millions of stars and other space objects, then stitch all that data together to create a complete view. This map was built from an incredible 3 trillion observations of around 2 billion objects collected over 11 years. It's the result of the European Space Agency's Gaia mission, and the level of detail is absolutely stunning. It gives us both face-on and side views of the galaxy, and it's more than just a pretty picture. Gaia has transformed our understanding of the Milky Way. In fact, scientists say it's caused a tsunami of discoveries, changing how we see the galaxy's structure, history, and future. But Gaia didn't just appear out of nowhere. That mission charted about 120,000 stars. Gaia. It aimed to map nearly 1 billion, roughly 1% of all the stars in the Milky Way. Launched in December 2013, with a budget of about $1 billion, Gaia was sent to a special spot in space called the L2 Lagrange point, about 1 million miles from Earth, the same region where the James Webb Space Telescope is parked. But Gaia isn't just about location, it's about precision. Gaia can measure the position of a star so accurately. It's like spotting a human hair from 1,000 kilometers away. That's how sensitive its instruments are. At the heart of Gaia are 2 identical telescopes, angled about 106 degrees apart. This setup lets it look at stars from different angles as the spacecraft slowly spins in space. The light from these stars is then funneled into Gaia's camera, the most powerful camera ever sent to space. It has 106 CCD sensors and almost 1 billion pixels. Here's how Gaia does its magic. First, stars pass through special sensors that record their exact position and motion. By observing stars over and over, Gaia detects tiny shifts in their position, what we call parallax. This tells us how far away they are. Next, the stars go through another set of sensors that break their light into different colors, wavelengths. This helps scientists figure out the star's brightness, temperature, size, and even what they're made of. Finally, some stars reach the radial velocity spectrometer. This part looks at how the light shifts due to movement, kind of like how a passing ambulance changes pitch. This shows whether a star is moving toward us or away, and how fast. Unlike most telescopes that focus on one object at a time, Gaia is constantly spinning and scanning the sky. It's like a giant cosmic scanner. This rotation lets it observe every star multiple times from different angles, building a super accurate 3D map of our galaxy. And the numbers? They're wild. Gaia observes over 2 million stars every hour, and it sends back more than 50 gigabytes of data every day. That's a lot of space homework. One of the coolest things about the Gaia mission is that it doesn't just take still snapshots of the Milky Way, it captures movement. Every star you see in the night sky is actually on its own journey, slowly drifting across space. This motion is called proper motion, and by watching stars over time, Gaia lets us rewind or fast forward the galaxy's story. We can literally watch the Milky Way come alive, stars swirling, drifting, even reshaping the constellations we think of as permanent. Over thousands of years, even those familiar star patterns change. But these motions aren't only about the stars themselves. They also reflect the fact that we're moving too. As our sun travels through the galaxy, it affects how we see nearby stars. When scientists used Gaia to study the motion of stars within about 1,000 parsecs of the sun, they could trace the path of our entire solar system as it orbits the Milky Way. And here's where it gets even better. By combining all of Gaia's measurements, how far stars are, how fast they move, and in what direction, we can now create 3D animations of the galaxy. Check out this one, 74,000 stars located within 100 parsecs of us. Some are drifting inward, others are flying outward. Most follow neat, circular paths through the galaxy. while others take a more wild route, bouncing above and below the disk. These visualizations are jaw-dropping, and they're not just pretty. They've changed everything we thought we knew about the Milky Way. The Milky Way is more complicated than we thought. For a long time, astronomers believed the Milky Way had just two major spiral arms. But Gaia's data has shown us a new picture. There are more arms, and they're messier and more complex than we imagined. The face-on view of the galaxy looks like something out of a sci-fi movie. A glowing golden center with graceful spiral arms curling outward like a cosmic whirlpool. Now flip that around. In the edge-on view, the galaxy looks like a thin brown stripe stretched across space, surrounded by darkness. But it turns out, it's not flat. Gaia revealed that the Milky Way's disk is warped like a record that's been bent. And this warp isn't sitting still. It wobbles over time, like a spinning top that's just about to tip over. What's causing this? We don't know yet, but something strange is clearly pulling on the galaxy, and it's a mystery Gaia might help us solve. One of Gaia's most fascinating discoveries is a giant wave of gas called the Radcliffe wave. It's huge, stretching about 9,000 light-years across the Milky Way, and it lies right in our neighborhood. Our own solar system sits inside the same arm as this wave, the Orion arm, and we're only about 500 light-years away from it. Before Gaia, this structure was completely hidden. We only saw scattered regions where new stars were forming. But with Gaia's 3D mapping, we could finally see the full shape. One giant, wavy ribbon of gas, containing about 3 million times the mass of the Sun. It turns out this wave plays a major role in star formation in our part of the galaxy. Even cooler, the Sun seems to be surfing along this wave. Scientists believe it crossed the wave about 13 million years ago and may pass through it again in the future. But what created this massive ripple in space? We're not sure. One theory is that a smaller galaxy collided with the Milky Way and caused the gas to ripple. But for now, it's just one of many mysteries Gaia is helping us untangle. Gaia is also helping us understand something wild, that a crash with another galaxy might have triggered the birth of our solar system. Enter the Sagittarius dwarf galaxy, a small galaxy that's been orbiting the Milky Way and crashing into it for billions of years. Compared to the Milky Way, Sagittarius is tiny, with just a few million stars. But even small galaxies can have a big impact. As Sagittarius got pulled in by our galaxy's gravity, it smashed through the Milky Way's disk at least 3 times. Once around 6 billion years ago, again 2 billion years ago, and most recently, about 1 billion years ago. Each time, it caused shockwaves, pebble hitting water. Those ripples squeezed gas and dust in the Milky Way, triggering bursts of new star formation. In fact, one of those collisions happened 4.7 billion years ago, right around the time the Sun and planets were forming. It's possible, just possible, that a galactic crash helped create us. Gaia might not be as famous as Hubble or James Webb, but it's changing how we see our galaxy in ways we never expected. Over the past decade, it has uncovered movement, structure, and history that were invisible before. And it's not done yet. We're only beginning to understand the story of the Milky Way, and Gaia is giving us front-row seat. Back in 2019, scientists made an interesting discovery. They found that before some of these galactic collisions, star formation in the Milky Way had actually been slowing down. But about 5 billion years ago, something big changed. Suddenly, stars started forming like crazy. In fact, nearly half of all the stars in the Milky Way's thin disk, where most stars in the galaxy live, were born during that time. Thanks to the super precise data from Gaia, we now have a clear timeline of how the Milky Way changed over time, and we're learning that even small galaxies can have a huge impact on shaping the universe. But Gaia's contributions go way beyond just the Milky Way. Its data has sparked breakthroughs across many areas of astronomy, from studying asteroids in our solar system to spotting hidden black holes, and even finding planets in faraway star systems. Let's talk about asteroids first. Gaia has tracked the orbits of over 150,000 of them, helping us understand the layout and motion of objects in our solar system. There's even a beautiful image showing the paths of these asteroids, from the ones near the Sun to the more distant ones around Jupiter. Yellow shows the Sun, blue marks the inner solar system, green represents the main belt between Mars and Jupiter, and red highlights the Trojan asteroids near Jupiter. One of the cooler discoveries, Gaia found that around 350 of these asteroids might actually have moons. These are called binary asteroids. Gaia detected them by spotting a slight wobble in the asteroid's path. A single asteroid normally moves in a straight line. But if it wobbles slightly in a repeated pattern, that's a sign it has a smaller moon orbiting it. And that same wobble trick has helped Gaia spot something even more mysterious: dormant black holes, also known as sleeping black holes. Unlike the flashy ones that shine brightly as they consume nearby material, these black holes don't give off any light. They're completely invisible in regular telescopes. Gaia found them by noticing that some stars were being tugged around by an invisible force. That tugging motion revealed the presence of massive, unseen objects, black holes. So far, 3 have been confirmed: Gaia BH1, BH3, and BH3. BH3 is especially interesting. It's not only the most massive stellar black hole ever discovered in the Milky Way, it's also the one with the widest orbit. It has a mass about 33 times that of our Sun and is located in the constellation Aquila, less than 2,000 light-years away. But Gaia isn't just finding black holes, it's also spotting distant planets. Recently, it helped discover 2 unusual objects: Gaia 4b, a super-Jupiter planet 244 light-years away, and Gaia 5b, a brown dwarf 134 light-years from Earth. These are really unique. Gaia 4b is almost 12 times more massive than Jupiter, orbiting a low-mass star, pretty rare. And Gaia 5b, the brown dwarf, is also paired with a low-mass star, which scientists didn't expect. What makes this discovery even cooler is that Gaia didn't spot them by seeing light. It found them by detecting the gravitational tug, or the wobble, these objects cause in their stars. This is the first time a planet was discovered this way using Gaia, and it opens up a whole new way of finding other worlds. Even after all these amazing discoveries, there's still so much we don't know about our galaxy. Gaia has finished collecting its data, but the discoveries are far from over. 2 more big data releases are coming. One in 2026 and another in 2030. These updates will make Gaia's already incredible map even more detailed. We'll get an even clearer picture of how the Milky Way is shaped, how it moves, and how it has evolved over time. So as scientists keep digging into Gaia's treasure chest of information, we're getting closer and closer to truly understanding the galaxy we live in, the vast, beautiful place we call home.